Set notation is a way to express information where we highlight the elements. Let's go ahead and look at an example that we saw from 3.1 using sets. In this example, we have a function with a domain and range again. With the following assignments. 1 goes to 5, 2 goes to 6, and 3 goes to 5. Now, by definition of relation, we can write this as a set of ordered pairs. So this is going to be 1, 5, 2, 6, and 3, 5. Before we go any further, let me just go ahead and highlight that these are sets, they're not intervals. They're again a set of ordered pairs, they're not a set of intervals. All right, so the first number is our input, and the second number is our output. So this is one type of set notation that we've already seen, and now we're going to introduce set notation for an infinite number of elements. And again, sets are going to be a way of how to highlight elements that we're looking at. So before we write out all the definitions, let me go ahead and do another example. Given the following inequality, we can write it as a set as follows. So here, let's just go ahead and highlight what all this means. Again, this is saying that X is an element of the set. This piece of information over here is telling us the condition to be in the set. And so this is telling us that this set is comprised of all elements that are in between A and B, including A and B itself. So we'll go ahead and do our definition of set notation, again using our number line interval notation and then translating interval notation into set notation. And last time we went over all 8 cases. This time we're only going to go over 6 different cases. But the last 2 are going to be very similar to what we see. All right, so let me go ahead and draw the table we had before. Okay, in this first one, again, we want all numbers in between A and B, including B, but not including A. And writing this in interval notation, this is again open parentheses A, B, close parentheses. And so writing this as a set, this is going to be all elements H, such that H is going to be strictly greater than A, but less than or equal to B. In the second set, we want all H values between A and B, including A, but not including B. So writing this as an interval, we have close parentheses A, B, open parentheses. And as a set, this is going to be all elements H, such that H is greater than or equal to A, but strictly less than B. And in our last case, we want all elements between A and B, but not including A or B. In this case, we're going to have open parentheses A, B, and then we're going to have a set of all values H, such that H is greater than A, but then less than B. So let's go ahead and do 3 more. Let me go ahead and copy the chart again. All right. In this top one over here, we want all H values such that H is less than A and doesn't include A. So writing this as an interval, this is going to be negative infinity A, open parentheses, and writing this as a set, this is going to be all values H such that H is strictly less than A. And in the next one, we want all values that are strictly greater than or equal to A, and writing this as an interval, this is going to be close parentheses A to infinity, open parentheses. And as a set, we're going to get that this is going to be all values H such that H is strictly greater than or equal to A. And for the last one, we want all possible numbers inside of our number line. And writing this as an interval, this is going to be negative infinity to infinity. And writing this as a set, this is going to be all values H such that h is inside our number line, and we usually just write this as r. Okay, so let's go ahead and just look at an example of writing our intervals as a set. So this is example 3. All right, so let me go ahead and draw the number line. And let me go ahead and highlight the sets. Okay, so now that we have all the information, we can go ahead and do this step by step. The easiest way to me is just to write this real fast using either inequalities or interval notation, and then writing it as a set. We can go ahead and just use inequalities. That way, writing it into a set will be rather quick. So let's go ahead and label this 1. We'll go ahead and label this 2, and we'll label this 3. So writing 1 as an inequality, this is going to be all x values that are less than or equal to -1 and strictly greater than -3. For number 2, this is going to be all x values that are less than 1 and greater than 0. And for number 3, this is going to be all x values that are less than or equal to 3 but greater than 2. So we can go ahead and write this as a set. So the set notation of this is going to be given by the following. So this is going to be all values. Let's call this value, for example, a. So all a values such that the following occurs. Either a is less than or equal to -1 or -3, or we have that a is less than 1 and greater than 0, or a is going to be less than or equal to 3 and strictly greater than 2. And so this is our highlighted numbers as a set.